Hi guys, so today we're going to be taking notes on page 67 and we're going to be talking about prime factorization. Now I know that on page 66 we're going to be talking about prime and composite numbers, so for now I want you to go ahead and just write in your table of contents, but we're actually going to skip that page because we're going to be doing an activity in class and we're going to be gluing it in that page. So go ahead and update your table of contents, and both of them are going to be December 16th. Okay. Now, we are also going to be updating some vocabulary words. So when you're done with your table of contents, go ahead and turn to page 63. And there are going to be 4 vocabulary words that you're going to have to update. So the first one is composite number, and the page is 511. And a composite number is a number that is greater than 1 with more than 2 factors. Okay, so here are some examples: 9, 12, 48, 50, 100, and there's a longer list, so it's going to keep going and going and going. Okay, now the second vocabulary word that we're going to be talking about is a prime number. Okay, and prime numbers are whole numbers that have exactly 2 factors. Okay, no more than 2. And here are some examples. We have 2, 3, 5, 7, 11, 13. All of these are prime numbers. Okay, and again the list keeps going. Okay. Now the third vocabulary word we're going to be talking about is prime factorization, which is on page 512. And prime factorization is when a composite number is written as a product of prime numbers. Okay, and we're going to be using something that's called a factor tree to find the prime factorization of composite numbers. Now, what is a factor tree? Well, that is the last vocabulary word that we're going to be learning. So a factor tree is on page 512, and it's a type of diagram that we use to find the prime factorization of a composite number. Okay, and it looks like a tree with a lot of branches and leaves, and that's why it's called a factor tree. Okay, so after you fill in all of your vocabulary words, we're going to go ahead and go to page 67. Okay, remember we're going to skip 66 because we're going to do something in class. So we're going to go ahead and start on page 67. So we are going to do 4 examples. 2 of them are positive numbers and 2 of them are going to be negative numbers. Okay. So we're going to start with 120. Okay. So what we're going to do is we want to try and break up 120. Okay. We want to look for 2 numbers, and when you multiply them, they give you 120. Now, this could be several different answers that you could come up here. So factor trees can actually look a lot different, but you still get the same answer no matter what. Okay, so I'm going to go with 6 times 20. So 6 times 20 is 120. Okay, now both of these numbers are composite, so I have to keep breaking it up. So I'm going to break up 20, and I know that 4 times 5 is 20. Okay, and then I'm going to break up 6, and I know that 2 times 3 is 6. Okay, now 4 is composite, so I'm going to break it up again. 2 times 2 is 4. Okay, now that we have all of ours, I'm going to go ahead and circle the prime numbers. So 2 is prime, 3 is prime, 2, 2, and 5. Okay, so those are my prime numbers. So I'm going to write my answer: 2 times 2 times 2 times 3 times 5. Okay, so if you notice, I have 1, 2, 3, 2. So I have 2 times 2 times 2. Then I have 1, 3 times 3 times 5, 1, 5. Okay. Now, another way I can write my answer is with exponents. So 2 to the 3rd power times 3 times 5. Okay? So we have our answer factor form, and this is exponential form, okay? All right, so let's do the other example, 36. And again, we want to try and break it up. So I know that 3 times 12 is 36. And I know that 3 times 4 is 12. And I know that 2 times 2 is 4. So again, we only want to circle our prime numbers. So 3 is prime and 2 is prime. So we're going to write 2 times 2 times 3 times 3, or we can write 2 to the second power times 3 to the second power. Okay? And again, this right here is our composite number. Okay? And then this is my factor tree. Okay? And then this right here is factor form. And this right here is exponential form. Okay? And it goes for all of them. This is always going to be the composite number. This is always going to be the factor tree. This is your factor form. This is your exponential form. Okay? Now, we're going to do some examples with negative numbers this time. So we have negative 70 is my composite number, and we have to do a factor tree. Now, I don't want you to freak out just because it's negative. We're going to pretend like the negative is not there. So let's say that this is just 70, okay? So again, we're going to break this up normally, okay? So I need to find two numbers that when you multiply them, you get 70. So I'm going to use 7 times 10, okay? And then I'm going to break up the 10. So 5 times 2. And again, 7 is prime, 5 is prime, 2 is prime. So I'm going to write 2 times 5 times 7, okay? Now, because this is not actually 70, this is negative 70, okay? We need to add an extra factor to make this a negative number, okay? So if I multiply 2 times 5 times 7, I'm going to get positive 70, but I don't want positive 70, I want negative 70. So I'm going to have to add an extra factor, okay? So I know that when I multiply a positive times a negative, my answer is negative. So I'm going to add times negative 1, okay? So if I multiply 2 times 5 times 7 times negative 1, then I get negative 70, okay? So this would be my final answer in factor form. Now this one's not going to have a exponential form because all of the numbers are only repeated once, okay? So you cannot write it in exponential form when you only have one of each number, okay? So it's pretty simple. The strategy is the same. The only difference is you have to have the negative 1 in order to represent the negative number, okay? So let's try another one over here. So we have negative 1,260. So again, we're going to pretend like this is positive and we're going to break it up. So I know that 10 times 126 is 1,260. And then we're going to break this up again. And I know that 6 times 21 is 126. And then I know that 3 times 7 is 21. And 2 times 3 is 6. And 2 times 5 is 10. Okay? So circle the prime numbers. 2 is prime, 5 is prime, 3 is prime, 7 is prime. So again, we're going to write our factorization. 2 times 2 times 3 times 3 times 5 times 7. Okay? Now remember, this is just for the positive. We still need to include our negative, so we need to add times -1. Okay? Now it doesn't matter if you add it at the front or at the back as long as you include it within your answer. Okay? So this one does have several that you can write over, so we're going to write -1 times 2 to the second power times 3 to the second power times 5 times 7. Okay? And this would be your exponential form. Your factor form, this is your factor tree, and this is still a composite number. Okay? All right, so those are your notes for today, and I'll see you tomorrow.